Hey everyone, I was thinking about this problem that we were trying to do in lab. Here is how I would go about this. First thing I want to do is figure out what order my genes are in. So I'm going to look here to the recombination rates, and this is going to tell me the order. So they're all under 50, so I like to start with the largest one and say R and T must be on the outsides. R and T are on the outsides, and B is in the middle. So this is our order. It tells us that the recombination rate between R and B is 5 centimorgans. So this is, let's just put 0.05. And B and T is going to be 0.09. Come on. And between R and T, we got 0.14. All right. Now, what's it give us? All right, so here's important. This is important up here because it tells us our linkage phase for our test crosses right here. So we started out with F1s. So they're all heterozygote. See, they give us right here. That's important. And that's what we're going to test cross. So we need to write down our linkage phase. R, T, B. And we've got to write it in the right order. Looks like it was already in the right order for it. Wait. Closest together is R and B, yes. Then B and T. Okay, so they're not in the right order already. R, B, T, R, B, T. And this is the only one I really care about because it's crossed, remember, with a homozygous recessive. So they're all going to be the same. So I always just look at this one. All right, so double recombinants. So that's the first thing you want to start with. Always start with the double recombinant. So we have 0.05, 0.09. What we do is multiply those together. That makes sense to me. 0.05 times 0.09. That's going to give you a double recombination rate. Double recombination rate of 0.45%. Okay. Now, if you have a double recombination, so remember that's where you have these guys right here, and let's say this one's up here. First it recombines here, and then it also recombines up here. But you have to remember when that happens, the one on the bottom went here and now goes up here and then back down to there. So you got 2 new gametes. The total of those 2 gametes is 0.45%. But each one of them individually is half that. So you take the 0.45% and you divide it by 2, and so you get a, if we just follow the trail here, you're going to get a little r, big B, little t. That's going to be half of this 0.45%. So that's going to be a 0.225. And then the other one is big R, little b, big T. That's also going to be 0.225. All right, so what I'm going to do, there's a couple different ways to do this. I could have went ahead and written down all the gamete types, but I'm just going to leave this linkage phase since this is another way to do it. All right, so that's the double recombinants. Single recombinants are this R and B and the B and T separately. So between R and B, you recombine 0.05, so you recombine 5%. But remember, when this one, so let's say we draw this, it goes there and then down, and then this one is going to go there and then up. So the total of those two together is going to be 5%. Each of the individual gametes separately is going to be half of 5%, so 2.5%. So let's write down what these are. The top one starts out big R, little b, little t, and the bottom one starts out little r, goes up to big B and big T. And we said that's 5% total, so each of these would have to be 2.5%. That's the first. Oh, no, you know what? Let's go back. I'm wrong. Delete this. Because you know what? That has to include the 0.45 double recombinants. So let's start out with our let's start out with this. Hopefully you're following me. We start out with this guy right here. Oops. The 0.05. And then out of that 0.05, so let's change that to percent. That's 5%. So it's 5% minus, we have to subtract out our double recombination rate. So 5% minus 0.45%. So that's going to equal 4.55%. That's what these two are going to be lines. That's what lines 3 and 4 are going to be combined. So we take a 4.55% and we divide that by 2. And now we have 2.275% are this, 2.275% are that. Okay. Then there's another way that these could have a single recombination, right? Oops, we just did R and B. So since we did R and B, next is going to be B and T. So it's going to be the same procedure. Sorry this is taking me so long, but I'm figuring it out as I go. So now imagine this one going here to here, then recombining to go up to there. Then the top one is going here and here, recombining to go down to here. So now we have a recombination between B and T. It tells us right here that this is happening at 9%. So 9% minus the double recombination rate of 0.45%. 0.45. That gives you 8.55%. So your total of those, let's see, let's write them down. The top one starts out with big R, big B, little t, little r, little b, big T. Okay, so the total of those is going to be 8.55%. 8.55. But since there's two of them, and every time one happens, the other happens at equal rates, so we divide it by 2. So that one, these are both going to be 4.275%. Okay, so we always have, when we do a 3-point cross, you're always going to have 8 possible gamete types. The last 2 are going to be your parentals. So just look at the linkage phase, leave it exactly the same. And this is super simple because now we know these all have to total up to 100%. So 100% minus the sum of lines 1 through 6, right? So let's add together all those. 0.225 plus 0.225 plus 2.275 plus 2.275 plus 4.275 plus 4.275. That gives you a grand total of 13.55% recombinant. And since you started out with 100, you just do 100% minus this. So 100 minus 13.55 is going to give you 86 0.45% are going to be parental types. And remember, you have lines 7 and 8, so you divide that by 2. And this is what we wind up with. 43.225% this way, 43.225% that way. And then, let me get this all out of the way. And the question actually asks for, let's see, phenotypes. It asks for what the phenotypes are going to be. So then we can just go through. We know that each of these gametes are going to be matched with all recessive from the test cross. So this one's going to be, let's see, I don't know what, white. So RR is white. RR equals white. Little t equals short. And little b equals small. And those are versus the wild types are red, tall, and big. Wild type. So then we just go through, and you could do this on your own, but I'll go ahead and do it. So this one's going to be white from the RR. It's going to be wild type here. So it's going to be tall. Oh, you know what? I'm sorry. They're given to me in a different order there. So it's going to be white, big, and short. Because this is small, short, and then this is tall, big. Oh yeah, that's in the right order now. Okay, so that's white, big, short. Then we've got wild type is red. Mutation is small. Wild type is tall. Red. Little b is going to be short. Sorry, it's going to be small. Whatever. Anyways, this is how you do it. You got to match those up.